To begin, statistical process control is a method used for measuring and controlling the quality of a process of systems. This is especially important when it comes to industry situations. More specifically to statistics, SPC primarily relies on the control limits that are established by the capability of the process fulfilling the needed outcome. These control limits are separated by an upper and lower control limit. When it comes to SPC, there is a wide range of charts that illustrate different aspects of the process. When it comes to the control limits of a specific system or process, the upper limit and lower limit set the standards of which the outcome should lie. These limits are found by collecting a sample, usually of 30 or more, and calculating the standard deviation and average. For a process-controlled system, the limits can help determine the adjustments that should be made by engineers, though engineers must consider the natural process variation of the system before making any changes to better fit the desired outcome. This would be the natural variance calculated from the sample data. It is best to understand the natural variation of the system before changing variables, since it could cause errors within performance. Here we have a small example of a quantitative process given by 4 observations with 5 subgroups. From there, we are able to calculate the mean of each subgroup, as well as the standard deviation of each subgroup. From there, we can easily calculate the averages of the mean and the averages of the standard deviation. Specifically for an S chart, the upper control limit is found by adding 3 times the standard deviation of the sample to the average, whereas the lower control limit is subtracting 3 times the standard deviation from the average. Based on the calculations, we are then able to see within the given data set the upper control limit and the lower control limit of which the process should stay within. The X-bar chart or mean chart can be found similarly by using the same ideas of the standard deviation chart.